thank you for coming to my presentation on progressive web apps. Obviously lots of people are talking about them at the moment and a lot of big brands have adopted them and support is really growing for them. So this presentation is designed to be just an introduction to some of the key concepts. So what they are, why we might consider using them and how to use them. So a bit of background, it's kind of widely accepted that a designer called Francis Berryman and a developer who works on Chrome called Alex Russell were the first people to coin the term progressive web app. In an article that Alex wrote in 2015, he talks about kind of where he believes the need for progressive web apps has come from. So he talks about obviously native apps being developed because users needed a better experience on mobile, but with that obviously we sacrifice a few things and linkability is one of them, and app stores become kind of the facilitator for the discovery of content. Also, we may need to maintain more than one code base if we've got a web app and a native app, and iteration is slow because of App Store regulation. So in the same article, he talks about a new kind of application, which he later goes on to call a PWA, and he defines kind of key attributes of what that looks like. So the first attribute is that they are responsive, so they should be able to fit any screen size. They're connectivity independent, so even if they don't have the full experience when you're offline or in limited connectivity, you'll still get some experience. You won't just be looking at like an endless loader or an empty screen. They deliver native app-like interactions, so they look and feel like a native app on your home screen. They're fresh, so a lot of the time with PWAs, you'll be served content from a cache, but that content is continually updated. Safe, they're served over HTTPS. Discoverable, so search engines can still find them. Re-engageable. With PWAs, they can access the device's hardware, so we're able to create push notifications. Installable, so this is different to the installation process for a native app. So instead of having to go to an app store, you can open a PWA in your browser, you get a little banner prompting you to add it to your home screen, and then it installs and sits on your home screen like any other native app. And linkable, so it's still really easy to share URLs. So Google obviously defined their own definition of what a PWA is, and I took this one from their code lab on progressive web apps. So PWAs provide an installable app-like experience on desktop and mobile that are built and delivered directly via web. So they're basically a web application that can be built using any framework or library, various technologies to meet a set of specifications. So it's not really a thing, it's kind of a group of technologies that meet a set of standards. Also, you've got one code base, so you don't have to maintain two separate code bases. You can just write a PWA using HTML, CSS, JavaScript. So Google also boiled down their kind of three main features of what a PWA should be. So reliable, they should load instantly and work in uncertain network conditions or even offline. Fast, and also engaging, so they should feel like a native app on the device. They don't have all of the access to your device's hardware that a native app has, but as support grows, they get more access. So they can launch push notifications, they can get access to your GPS or your camera, so they feel more and more like a native app. So these are some of the brands who are using them now. I actually use the Twitter one because I don't really have enough space on my phone to have a native app. And I can honestly say it looks and feels like the native app. It's cool. And also Apple-made service workers, which I'll talk about later in the presentation, but they're a really integral part of what makes a PWA a PWA. And Apple gave them support in Safari for iOS 11.3, which acted as a kind of catalyst for more brands to get behind them and start using them. So this is kind of an example of what they look like on your phone. So here, Flipboard is the PWA. It sits at the top of the task switcher. So when you're switching between tabs, it won't live inside your browser. It won't live as a tab within Chrome, for example. And then this is a GIF that Google showed at their 2014 Chrome Dev Summit, which basically shows the installation process for a PWA. It's quite fast, so I'm not going to try and talk you through it all, but essentially you visit the website and you get prompted with a banner to add to the home screen. That then downloads and sits on your home screen and opens without all the browser UI that you would get from just a web app. So I think as well, the add to home screen banner, it used to be the case that you'd have to have visited a website, I think it was twice within a certain time frame in order to be shown that banner. But now, as long as your site engagement score is high enough, that can actually be triggered the first time you visit the website. This is hectic, so I'm not going to talk through all of it. I just wanted to do a kind of top line overview of some pros and cons, because I wanted to talk about pros and cons of PWAs, but it wasn't kind of clear if we were comparing them to native apps or to web apps. So in essence, kind of native apps obviously provide a really good experience for the user on mobile, but they're difficult to maintain and to develop. And there's actually more barriers to a user downloading them in the first place. Web apps, obviously easy to develop, easy to maintain, but the user experience isn't optimal on mobile. And then PWAs kind of sit in the middle, so it's a better experience for the user on mobile. It's easy to develop and maintain them, and kind of as more support grows for them, they'll feel more like a native app. So there are kind of three main criteria that you need to meet if you're thinking about turning your web app into a progressive web app, kind of like baseline criteria. So the first is your web app manifest, which is essentially just a JSON file that contains metadata about your PWA. This is one I took from Create React App and just added a couple of bits just to show you kind of how you could configure this. So I'll just talk you through it. The short name relates to the name that's shown on your home screen after the PWA has been installed. The name is what's used to prompt the user to actually download it in the first place. Icons, self-explanatory, but if you provide icons with these dimensions, Chrome will automatically scale them for different devices. Start URL is just where the app will open once it's launched. A display allows you to configure what browser UI, if any, you want when the app launches. Theme color relates to just the splash screen. No, background relates to the splash screen, and theme color relates to the task switcher toolbar. So the next thing is a service worker, and as I mentioned, they're a really, really important part of PWAs. This is how Google defines them. So a script that your browser runs in the background, separate from a web page, opening the door to features that don't need a web page or user interaction. Essentially, they provide a foundation for your app to work offline. and also to do things like send push notifications even when the app isn't open in the browser, background sync, that kind of thing. And I've also just listed kind of some more features of service workers. So it's just a JavaScript file. They listen for events and they can intercept network requests and respond instead. Instead of making a network request, they can respond with resources from a cache. They can pre-cache content, so when you load it, you can get instant loading. They can access device hardware, so as we talked about, they can access your GPS and your camera. They can work alongside the Notifications API and Push API to create push notifications, which is cool. They run in background, separate from the main browser. They run over HTTPS, and they enable background sync. So you can postpone a task until you have network. And then I've just, when I was writing this, I thought it still isn't that clear what a service worker is and how it works. So I've just done a quick example of how a service worker might respond to a fetch event. So the user launches your progressive web app and a GET request is made to load resources. The service worker then intercepts the request and they can check to see if whatever you're requesting is already in the cache. If it is, it can respond to that request with the resource from the cache, so there's no need to then send on a network request and for the user to wait for that resource. It can then refresh the cache by continuing on to make that network request and update the cache so that next time they'll get more up-to-date content. And then if the resource doesn't exist in the cache, the service worker can respond with a fallback. So for example, Chrome, their little dinosaur game if you don't have any internet connection, but better. So service workers have got a life cycle, which is really important for a couple of reasons. The first is so that you don't have two versions of your site running at once, which I'll talk a bit more about, but essentially the service worker is serving resources from its own version of a cache. So if you have two running at once, you're likely to have two different versions of your site running. And the other one is just to make sure that you can get your service worker ready to take over the site without disrupting the one that's currently in use. So the first event is the registration. So here I've just done a really basic sample of what that might look like. So we check to see if the browser supports service workers. Not all do. And then if it does, we just register it to run in the background. You can pass in a scope as well to the register function if you don't want your service worker to control your entire site. Otherwise, it will default to the location of the service worker file relative to your project. The next is the install event. So this will only fire if the service worker is different. So if it's bytes different, it will be downloaded by the browser. Or if there hasn't yet been a service worker registered to that URL. It's a good time to cache resources as well, so that next time it loads, we'll get an instant load. As each time we register a service worker, we can update that cache. And then if there's an existing service worker, it has to wait for all pages of the site to close before the new one can take over the site. And again, that's just to make sure that we don't have two versions of the site running. So it's not enough to just refresh the page. And the next one is activate. So this will only fire once the old service worker's completely gone. So it's a good time to remove outdated resources from the cache because there isn't a service worker still using that cache. And this is now it can listen for events. And I've just done, again, a very basic kind of example of how a service worker might respond to a fetch event. So here we might check to see what kind of resource is being requested. So in this case, if it's an image, we'll try the cache first and see if we've got that file available to us in the cache. If we do, we'll respond to the request with that. If not, we'll try and make a network request. And otherwise, the opposite. So we try the network and fall back to the cache if that hasn't worked. There's a ton of different caching strategies. It's actually a really good resource from Jake Archibald called the Offline Cookbook, which kind of outlines different strategies, when to use them, pros and cons of each, that kind of thing. In a couple of slides, I'll just talk about some of the more commonly used ones. And then it's redundant, so it's replaced, the service worker's replaced by another one, and then the whole process starts again. Those caching strategies I was talking about. So the general kind of best practice is that non-critical requests shouldn't make a network request at all. So I'll just talk through them. So the first one is cache only. It's a good way of, you can cache the whole app shell, so you instantly on load, you're faced with kind of something that looks like an on-brand app as opposed to just a white screen loading. Ideal for static assets. Network falling back to cache is ideal for resources that update frequently, and it's essential that we've got the latest version. And then stale while revalidate, I've seen quite a lot. So this is kind of an illustration of what that looks like. It's ideal for resources that update frequently, but we don't need the latest version necessarily. So here we make a request, which is intercepted by the service worker, which goes to the cache, retrieves the resource that's been requested, returns that to the user, but also makes the network request and returns the response to the cache, so that next time it's been updated for the next time the user requests that resource. And then the last criteria is that it just needs to run over HTTPS. I mean, service workers can intercept all requests, so it's just malicious intent. Protect against. And then just some best practice and watch outs that I've experienced and also seen other people talking about online. So the first is, it's a good idea to tell the user if they're using a cached version of the site or if there are updates available. It might be a good idea to let them update their website, the app, rather than just updating it for them. The first load of a PWA will still be slow. The more the user interacts with the PWA, the more resources will be cached and the better experience they'll have. And then there is still feature inconsistency across browsers. Even though a lot of browsers do support service workers now, they don't necessarily support all features of service workers, so it is a good idea to check. And then development of PWAs can be really tricky from experience. You're just kind of always fighting against the cache. You find code that you thought you deleted 2 hours ago and vice versa. You can't find code that you've added. It is a bit of a nightmare, but Chrome DevTools has got quite good support for PWAs, including overrides, which just help development a bit. For example, you don't need to close the tab, close the window every time you want a new service worker to take control. You can override that and skip the waiting phase. And then I've just put in some resources that I found quite useful. So is service worker ready checks what level of support the browser has for service workers. Lighthouse, you probably heard of, that's got a whole list of different criteria that they're looking at when they audit a PWA. offline cookbook. PWA Builder, which I haven't used, but people are saying it's pretty good. And PWA Rocks, which is good, because you can have a look at the source code of PWAs and see kind of how they're configuring their service workers. Because I guess the cool thing about them is that you can basically configure service workers to do whatever you want. It's not an out-of-the-box solution. You can kind of tailor it to your needs and what your app needs. Thanks.